All right, we'll go ahead and get started here today. Thanks again for joining us. We've got a part two, a part one today, and a part two on Friday on going back through the 2021 IECC commercial. I know those that joined us a few weeks ago on our presentation for electrical and lighting. There'll be some more of that in here as well, but I did not spend too much time since we went through that, and that is on our webinar. But thanks again for joining us today. Today's webinar is being recorded. It will be uploaded to the YouTube channel, which you can find by searching SPEER on YouTube, SPEER, or you can go to our website at eepartnership.org, and under the news section, you'll find a resources page. And on the resources page, you'll find a link to our channel. Within 72 hours of today's presentation, you'll receive a course evaluation email from Kathy Lawrence. Please complete the survey and send it back to her to receive your course completion certificate that will contain the course ID number you'll need when using it when you're reporting your CEUs to ICC. As always, I have the chat feature open. Please use that to report any technical difficulties you might have, and also the Q&A session is open as well. Please use that to post any questions you might have, and we'll go through them as they show up in today's webinar. So there will be some stuff in here that's listed that you've probably seen before. I just wanted to make a complete version of this. This is one that I'm using in-person meetings as well. So any feedback and updates that you can provide for that would help me tremendously. So let's get started with this. Those that don't know who SPEER is, and if it's your first time, thanks for joining us. We are one of 6 RIOs, which is basically a regional energy efficiency office. And so we're a nonprofit. And what we do is kind of the education side of SECO, where we actually teach and train for energy code adoption and enforcement throughout Texas and Oklahoma. So we can do this in person, we can do webinars, we can do field trainings. Also, I've done IECC test prep training as well. Sometimes that's a one-on-one. The price is always right, it's always free. We don't really charge for that. That's kind of what we do and what I do on a daily basis. I can help with questions regarding energy code, IECC, ASHRAE 90.1. I can help with questions of plan reviewers, building officials, and also third-party inspectors. We're always happy to help. So we continue to assist several cities with their adoption of the 2021 and how to navigate through some of the additional amendments that other cities are adopting as well, and that lessens the impact of the adoption for most of your building community. My contact information will be at the end of this presentation. Please feel free to reach out to me with any questions. Also, feel free to share that if you'd like to anybody that I can be an assistance to. Our agenda, we're going to go through the breakdown of the energy code. I'll kind of go through that pretty quickly. We've done that before in previous slides, but there's some of this stuff that we like to also always be part of our agenda on some of our webinars. We'll go through the energy code and state law, and then we'll dig into the changes of 2021 IECC commercial. I went ahead and broke it into 2 parts just because there's a lot of information there, and I don't really like going super fast and not allowing time for digestion and also questions that pop up. We're also going to try something new with these 2. At the end of the presentation, I will stop the recording, but I will remain online. And so if we go offline and you want to talk about things more specific to what you saw in the webinar, I've got the code book right here with me. We can dig into that and talk about it in more detail. So I will stay on after the recording. You are welcome to do the same. So let's get into this. So as we always talk about the historical improvements of it, this chart just kind of shows how we're continually diving down towards a net zero in the commercial code as well as the residential code for IECC and for 90.1. As you can see, 90.1 is on basically on point more than IECC is to get to that net zero by 2030. So each time we see, of course, from the 09 to the 12, there was a big drop, and then the next drop happened in 21 for this cycle, and then the 2024 will probably be another drop of another 8 or 9% as well. So the Code Council released the new framework. It's kind of based on an ANSI standard process now, which is good for everybody and the public. It opens it up to everyone for voting. There's proposals that are made, and time is given for the proposals to be either accepted or considered, and then adjusted, and then brought back as a new proposal, making it to its final polish, and then making it into the book. So It's a good thing that they've done that. It used to be a more speedier process. There was not much time to do proposals. You didn't really have time for any adjustments or changes. You had to wait till the next cycle. So thankfully that was changed. The Texas adoption process is still the same. Unfortunately, with this last legislative session, we did not get a new adoption of the code. Instead, property tax deal was taken over this. So we're hoping this is going to show up in the next session as well and be prepared for adoption at that time. Probably not to the latest code of 2024, more likely either an 18 across the board or a 21 with amendments possibly. Is how that's going to work. And we're keeping in touch with that. We're keeping in close tabs with that as it goes through. And we work diligently just to educate as it comes to new legislative sessions about the importance of the adoption of new energy codes. So unfortunately, the state of Texas is still under the 2015 IECC. A lot of cities around North Texas, Central Texas, and South Texas around major metroplex have already adopted the 2021. Others are still on 15 and 18, but every time Kathy updates our Excel spreadsheet showing that the new cities that are adopting, we're usually adding 8 to 10 to 12 every other month. So it's still happening in Texas. It's happening a lot where people just jumping to the 21. I think a lot of that took place because they thought Texas was going to adopt that. And so maybe we'll see that slow down, but hopefully not. Other cities deem that it is important to stay up with energy codes. So as we talked before on the proposal changes, 114 in total, but not all of these were approved. The subcommittees vetted through a lot of them and pushed through, and then they decided as a committee on what to take. Thankfully, there was a lot of them in here that probably didn't make a whole lot of sense to be proposed and adopted, but some of those did make it to the final cut. Out of those final cut, we had 58% administrative, 21% decreased energy use. 19% there was no impact, and 2% actually increased energy use, probably just some clarification or modification to some of the requirements caused a little bit of an increase. Of course, with the change in climate zones, which we'll see here in a couple of slides, that also made an adjustment to some of the increase in energy use. So out of that, most of it was envelope adjustments coming from the walls. And then most change type was from the R value and U factor tables that are listed there. So as we see, opaque surfaces got 21 of those, and then fenestration, and then of course 5 and 1. That's just the infiltration in general. And then change by type, basically the largest was the U value and R value, U factor and R value tables were adjusted for the climate zones. And then you got 11 of them, which were basically just clarifications on how it was written. Still in play, anything that's considered residential or commercial. So if it's retail on the lower floor and the next 2 floors are apartments, as long as it's 3 stories or less, it's still residential for the 2nd and 3rd floor, and retail is commercial. If it goes to that 4th story, then regardless of what floor has what dwelling, it actually goes to commercial for all 4 floors and above. So getting into this part of it now, some of it is wordy. I tried not to do just verbatim out of the code. I tried to do some just some commonality language in here to understand it. But some of this I'll read off the slide, and some of this I'll just go through some of the highlighted part of it. But just highlighting a few sentences out of chapter 1. This sometimes can help the code official better understand your intent and be more flexible with the understanding instead of hardlining each requirement. So the code shall regulate and design construction. Basically, it's the code is intended to provide flexibility to permit the use of innovative approaches. In other words, the code official should not just be hardlining it with materials or processes. If you can show that it's meeting the intent with these innovative approach or innovative products, it should be allowed. And we're building also includes residential and building and commercial portions. We just talked about that. Commercial documents shall be prepared by a registered design professional. So I highlighted that, or at least underlined that. So a lot of times cities get permit requests and permit documentation from things that there's really no telling who's actually done it. It should be a registered design professional. They should stamp it or at least sign it with the company name and their name as a signature to it, saying that they are a registered design professional. It shouldn't just be any contractor or Joe that's filling those out. So those are one things that when they turn in for comm checks and you're going through plan reviews, look for a stamp either by an architect or a design or another type of company that has someone that's a registered design professional. This kind of goes without saying. Everyone's probably already been doing this up to this point anyways, is allowing digital construction documents to be acceptable. It is now written into the code book that you can now accept digital construction documents. In other words, someone can email you floor plans. Before, it used to have to be turned in via paper, and you had to walk to the city and go turn it into a permit department. Now you can just email all those. There's a lot of cities that have adopted the online permit request for digital stuff through their websites, and you can just do everything online and get a permit accepted through there. It's now written in the code book for being acceptable. This is a list of requirements that are related details that are needed for when you're applying for the permit. The two that have been added is the first one, energy compliance path. In other words, you have to explain how you're getting through the code. Which pathway are you following? Is it prescriptive? Is it performance? Is it a UA trade-off? Not really for commercial, but for residential, is it Energy Star? You have to put that in your permit request when you're applying for permit. The city plan reviewer may not ask or require some of these, but if you're following the IECC, this is the minimum to be turned in. With the 2021 energy compliance path being used, must not be labeled on the document. In other words, in addition to the air barrier and air sealing details, the building must be listed, or building type must be listed. This includes materials or systems being used and the location of the air barrier. That's something new, is the location of the air barrier. So the last two, location of daylight zones, must be listed on floor plans, and then the air barrier and air sealing details, including location of the air barrier, must also be listed in your permit request as well. So this is in conjunction with and added to an addition when you're doing the comm check to be turned in for that. I don't have a lot of notes with this. Basically, just the first few slides here are just definitions that were added. They defined biomass and biogas. These were splits from just biorenewables, and they've basically further described what each of those are. We don't see a lot of that happening here in Texas. One that we do see happening a lot in commercial is the data center is now been defined. It's a room or series of rooms that share data center systems whose primary function is to house equipment for the processing and storage of electronic data, that has a design total IET electrical or equipment power density exceeding 20 watts per square foot. In other words, there's a lot of equipment pulling a lot of energy in there. It probably is going to be conditioned, but there's going to be specific requirements because it's listed as a data center, and that should also be listed on your plans when you're turning it in for a permit request. So direct digital controls is a type of control where controlled and monitored analog or binary data, such as temperature and contact closures, or all doors closed, all windows closed, things like that for security, are converted to digital format for manipulation and calculations by a digital computer processor. So a lot of this they have to define all this because a lot of these are showing up more and more as more people need the data from building maintenance, and it's actually having the housing in separate rooms. So one thing that's also is they define the fan efficacies. There used to be just different electrical outputs for fans. Now they're identifying the fan efficiencies. There's fan embedded. There's fan array. There's an FEI that's new. That's now the fan energy index. There's the fan nameplate electrical input power. And then, of course, the fan system electrical input power as well. So they broke that down. Since there's efficacy tables now for fans, they had to identify and define each of those different types of fan arrays, and then what actually is considered fan energy index. We talked about this just a minute ago, but there was a change in the climate zones. As we can see here, this is the newest table out of the 2021. In Texas, the counties that changed was Cameron, Dallas, Ellis, Hidalgo, Johnson, Navarro, and Tarrant County. And so they actually just moved up. So as we get warmer and drier, warmer and more humid climates, and differences of what it used to be. So it's now actually moving further north. We've got the addition of 1A now in the tip of Texas that was not there before in the 18 and before. So that is a very hot and humid climate. So that's now in Florida as well as in Texas. So those are just a few changes that happen with that. Installation mark installation. So this was always kind of in the book to begin with from the beginning. Basically just saying that the manufacturer needs to have visible or observable marks showing the R value of the material that's listed. However, now we have products that are being installed such as spray foam or blow-in wall insulation that does not have a readily observable R value listed on the mark. With that now is the modification stating that an installation certificate must be left immediately after installation by the installer in a conspicuous location within the building to certify the installed R value of the insulation material meets the requirement of the climate zone that you're in. So that basically says that you've got to have a certificate, which looks similar to this. This is a residential certificate, but it looks similar to this. It should list the address, the name of the building, or also the name of the construction company, the name of the insulation installer, and the date of installation. It should also list type of insulation used, and the total R value installed should also be listed. If it's spray foam, it's also looking for the type of foam. Is it open cell? Is it closed cell? Because you have to look at that, especially with commercial. Is there a flame retardant already in it, or is it going to have to be coated? Each section of the thermal envelope should be listed, and then each R value and thickness of the material that's installed should also be listed on here. This is to show compliance with that. A lot of times in commercial and in warehouse, you have laminated insulation on radiant barrier that's drooped or draped from the ceiling. A lot of times those do not have R values on them. And so that also needs to be listed on there as well. So that's to verify from the inspector's point of view. It's to easily verify that it's done. Now, if you have digital formats and you could carry the permit documents with you on an iPad, or if you've printed them out, you may have the plans right there in front of you, and it shows the table that's showing where the R values are supposed to be, but you still don't know if that's actually what was installed. So you leave it to the responsibility of the installer to actually leave a certificate that states what they've done and how what they've installed, what R value it meets. And then you just inspect on how well it is insulated. So those are now required. Some of the blending of the residential and commercial continues to happen through the code book. They're bringing things that make sense to residential to also bring it into commercial, because it makes sense to do it that way as well. So to remove further confusion with the compliance path, sections 401.2.1, which is the IECC for both prescriptive and total building performance, and C401.2.2, which is the ASHRAE, were added. So basically, it just adds these to the code book, trying to streamline that. More and more of the commercial IECC is kind of blending in with the same requirements as the ASHRAE 90.1. So you could reference and do one or the others. Most cities allow you to follow an ASHRAE 90.1 path or follow the commercial section of the IECC. But as time goes on and each code cycle comes out, we can see more and more of the blending of the ASHRAE 90.1 into the IECC. So they're kind of morphing into the same. Like residential, a thermal envelope certificate is now required and should be left on site after the final energy inspection from the third party. And it should be required if the third party's on site and if they're contracted to do that, and should be required for final CO being issued. So this is kind of off to the right as an example of what we call the panel sticker, which was on the electrical panel that showed the third party energy has verified all of these sections of the building's thermal envelope and actually has listed the R value that was actually there when they inspected it. And there's also testing involved if there's testing involved for commercial, but for residential, it is required. You have duct testing and you have blower door testing or infiltration testing for the envelope, and it must be listed there as well. You've got the windows, you've got the doors, and you've got mechanicals that are listed as that on that as well. Now also provides information related to photovoltaic systems. So if there's solar on there, that should also be listed. New to this sticker is also, just like in the very first few slides we had, there's a requirement that says what pathway has been followed. So if the other person that's on site doing the inspection was not the one that did plan review or did not do first part of the inspections, they just need to know what pathway are you following. Is it the ISRA 90.1? Is it performance? Is it prescriptive? Is it a trade-off? It must be listed on that as well. This is just for ease of compliance to be shown for the code official or third parties to list this on here so others can see as they go through the inspection process. Low energy buildings and greenhouses, this continues to be modified as, I guess, conditions arise that show up to show that they need to make just additional adjustments. But basically, it's added a thing in there for number 3, or actually it's item number 2 has been included. It just says any space that is not being conditioned is considered a low energy building. So any space not being conditioned. A lot of times that's greenhouses as well. Sometimes depending on what's being grown, there may be some type of conditioning or heating that's happening in there. And then that fits into a different category as far as being conditioned. But this has added a section that just says any space that's not being conditioned is considered low energy buildings and is not required to meet the compliance of the code. With greenhouses, though, again, and we just said that it's just a lot of it being morphed into something. There's a lot of exceptions in here. They're trying to further define. I'm sure it's probably not as clear as it could be, and it will be adjusted as time goes on. But it's an addition. Greenhouse structures or areas that are mechanically heated or cooled. Here, it could be listed under low energy, but now it's saying if it's being heated and cooled, that comply must follow with all of the following shall be exempt from building and envelope requirements of this code. So if it's a specified greenhouse and it is being heated and cooled, it can be exempt depending on, but like the first one, exterior opaque envelope assemblies comply with specific sections. An exemption, if it's considered low energy greenhouses, it now complies with a different section. The interior partition building thermal envelope assemblies that separate greenhouses from the conditioned space must comply. That's warehouses that have, or greenhouses that have possibly a warehouse space that's being treated differently, or it has an office space under the same roof as the greenhouse needs to be treated differently, and the partition walls between that must also be treated differently. Fenestration assemblies that comply with the thermal envelope requirement in table C 402.1.1.1. The U factors for the roof shall be the roof assembly or a roof that includes the assembly and the internal curtain system. Exception again is the unconditioned greenhouses. So removed from all of that, if it's not being conditioned, heated, or cooled, it's now exempt. So fenestration thermal envelope maximums for skylights, the U factors have now been moved to 0.5 and vertical fenestrations 0.7. There's a new table that's been listed that for vertical fenestrations that's in that. It's a small table. I didn't put the table in, I just wrote it in the slide. The minimum R values, this is anything that's in blue is a change from the 2018 to the 2021. And as you can see here with climate zone 0 through 3, there was a lot of adjustments that happened. Most of the changes made were increases of R values for metal buildings, attics, and then you've got metal building, metal frames, and wood frames as well. A lot of them have been added with the continuous insulation being added to it to break the thermal transmittance of heat through the wall. So that adds a lot of power to uphold the R value that's in the cavity. So they're adding continuous insulation to that as well. There's a lot of footnotes that's added to that. I did not add those here, but that's listed in the book. But as we see, just for example, climate zone 2 metal frame, you've got R13 plus R7.5 continuous. That's the only allowable for the group R wall for that. And all others are 13 plus 5. So that's the continuous insulation that's in there. A few more changes made to the table C402.2.4, and they are mandatory, or as we say now, required. The word mandatory is no longer in the code book. You can see in zone 0 and 1, R13 is now required in the joist and framing. And in zone 3, unheated slabs for building type R is now required to have R10 for 24 inches below. That still brings up the whole, if it's in a high infestation of termite area, that is usually amended by the cities to say that it's not required to have slab edge insulation because you're in a high termite area. The last that we know of, a lot of these calculations were broke in the 18 or broke in the com check section. So when you're trying to do some of this, it may not make sense. We're unaware of it's actually being fixed. I did hear from a conference, I think at the beginning of the year, they were working on I think the new version of the com check is out, and I believe that's now been fixed. Lastly, there are some modifications for the F factors in zones 3 through 8 that align with the ASHRAE standard 90.1-2016 requirements. Again, just going back to the morphing of more like the ASHRAE 90.1 standard, as we had seen before previously. Minimum U factors, so there were some changes made. Most of these, as you see again, 0 through 1, 2, and 3, most categories have changed U factors. The U factors decreased for the most part, which means you've increased the insulation value of it. Again, aligns more closely with the 90.1 and how they're showing it in their requirements. So we're just getting still to that part of it. Some confusion was cleared up with this. There used to be hinged, non-hinged doors. Then there was swinging and non-swinging doors. They took the hinged doors out and just listed it in one table. Now it says swinging and non-swinging doors versus having the hinged doors in a different section of the book. So it fixed the confusion on how it's to be used and consolidated it into one section and listed it under a U factor table for doors. So clearing up the clarification for that part of it. Roof insulation requirements are clarified and separated for compliance with either the U factor or R value method in these sections. As we can see, I won't read through all of these, but you have tapered and above deck insulation based on thickness. You have suspended ceilings. You have joists that are staggered. And then you have roof assemblies, and it just gives different requirements to be able to meet the roof assembly and insulation requirements per the code. Slab edge insulation, we talked briefly about that just a second ago, but it says where installed, the perimeter insulation shall be placed on the outside of the foundation or inside the foundation wall. The perimeter insulation shall extend downward. So it explains exactly how that's supposed to be installed. As we say, most of the Texas area, at least north central Texas, is under that high infestation of termites and usually is amended out of the code and not required to have slab edge insulation. But there is an exemption, basically where the slab on grade 4 is greater than 24 inches below the finished exterior grade, it is not required. So there's still exceptions to that to say, you know, you don't have to do that depending on how the slab was poured. Something that's been defined now and added in this is airspaces. So where the R value of the airspace is used for compliance in accordance with the section C402.1, but then specifically it says the airspace shall be enclosed in an unventilated cavity constructed to minimize airflow in and out of the enclosed airspace. So just because you have, and this is a poor picture of one, I could not find one on Google to show what exactly this was pointing at, but behind the brick here, they're showing there's an airspace, 1-inch airspace. But as we see, it's open with weep holes at the bottom. That cannot be, that R space of that gap cannot be considered in the total R value of the wall cavity. If it was some type of system where there was no air moving in and out, top and bottom or front to back, in that 1-inch airspace, then you can basically say how much R value is a 1-inch airspace. And you can add that to your total structure R value in each cavity to meet the requirement of the insulation required for that climate zone. But with this, as we see here, this one could not be considered because of the weep holes and the fact that the brick ledge is open at the top, allowing for that drainage. It cannot be considered, R value cannot be considered in the cavity insulation. In climate zone 0 through 6, not more than 40% of the gross above wall area shall be vertical fenestrations, provided that all of the following requirements are met. So this is an increased vertical fenestration area with daylight responsive controls. So they added the requirement a number 3 requirement saying daylight responsive controls are installed in daylight zones. So in buildings not greater than 2 stories, not less than 50% of the net floor area is within a daylight zone. In buildings 3 stories or more, not less than 25% of the net floor area is daylight zones. The number 3, basically daylight responsive controls are installed in daylight zones. And then number 4, visible transmittance of vertical fenestration is not less than 1.1 times the SHGC. So this is specifically talking about the daylight responsive controls and how these things are handled. It's more and more of that's coming into the code. Minimum fenestration or minimum skylight fenestration area. Skylight shall be provided in enclosed spaces greater than 2,500 square feet in floor area that are directly under a roof with not less than 75% of the ceiling area with a ceiling height greater than 15 feet. So there's a requirement and a specification of skylight fenestration area for being minimum. Of course, it says if they're being used as a lobby, an atrium, a concourse, a corridor, storage space, a gymnasium, exercise center, convention center, automotive service area, space requiring where manufacturing occurs, non-refrigerated warehouse, retail store, distribution, sorting area, transportation depot, or workshop. So that defines where this minimum skylight fenestration area needs to occur. Lighting controls for top lit daylight zones. So before we just had daylight zones. There wasn't any definition or breaking down of where is the daylight zone coming from. Now in the 2021, they've split that. They've added a top light and a side light, but they still are considered daylight zones. So if you ask for permit documentation to show where are my daylight zones, they will include top light and side lit zones that are all part of that daylight zone. So it's just encompassing all of that to see which getting to that whole controlling the lighting depending on how much daylight's coming through the windows. You're now controlling how often or how much power is being driven to that lighting or luminaires in that space. So I just got ahead of myself there, but that's what that is. It's in addition to that being said that the daylight zones shall include top lit daylight zones and side lit daylight zones. So they're all encompassing under daylight zones, but they can be broken up into different ones. And then there's different requirements for each one in the book. It's about a 2-page lengthy that goes through that and talks about how that's being done and how it's split into that. Air leakage. So not a lot of construction is happening that's being air tested or air leak tested, but there's modifications that happen. So air leak requirements are expanded to include requirements for non-residential air leakage testing and for building envelope performance verification for buildings that are not being tested. So the envelope must comply with the section C402.5.1 through 5.11.1 or be tested and specified under section C402.5.2 or 402.5.3. So when the building is being tested, it must comply with different sections. And when it's being just verified, it's also got to be verified under different sections as well. So that's splitting that up to just say, if you're going to test it, then you need to comply with a different section. That usually gives an easier way of inspection is because you're just relying on the testing data to say, is it actually meeting the requirement for a tested building for air infiltration? And then the other one basically says you need to identify and verify the compliance for the air barrier, where it's installed, how it's installed, which components of the building make up the air barrier, and how they're actually performing as well with that part of it if it's not being tested. So for now, they're giving you the allowance of going through that and actually being able to do one or the other, but there's different requirements for part of that. And then operable openings, interlocking. So this is something that's new here. So roll-up doors that are 40 square feet or larger must be interlocked to control the HVAC system to either raise or lower the set points to 90 degrees for cooling and 55 degrees for heating whenever the door is opened. So this is showing a restaurant. It doesn't have to be. There is another requirement for when you have a loading dock with doors that open up, that this is more of a a restaurant style they've got roll-up doors that during certain times of year they can roll the doors up. We've talked about that before, but there's a lot of them that I've gone around to different conferences, met with different building officials. A lot of them say that they're not really looking for that, or some of them say that's a specific thing they do look for. If they see roll-up doors on the plans, they want to know what controls are going to be installed to actually comply with the code for it to have a set point change when the door is operable or open. So a lot of times it's, this, they show the door halfway open. So I'm sure that doesn't matter if it's halfway or all the way open. Once it's open, you're allowing air to come in or out of the building, changing the climate that's in there. So you need to have a set point that moves it to 90 degrees for cooling and 55 degrees for heating when the door is open. So my next slide is actually showing the end of part one. I'll actually keep going. I got a little ahead on that. It went a little quicker than we wanted. There's a lot more to cover in part two, and then we'll stop it shortly after that. So I won't be going back through the same agendas. We'll jump into C403, the building mechanicals. And so with that part of it on the mechanicals, here's kind of a breakdown of what happened in the code. So as you can see, the majority of it was HVAC controls. So that's 33% of that. There were 7 of them. Then you had 6 for energy credits. That's the points that you have to get when you're actually doing your energy credits for the additional energy efficiency measures. And then you've got HVAC efficiencies were changed as well. There were 3 of those that equated to 14%. Again, aligns with the 90.1 and how that was actually the requirements for that. Also, there's updated federal minimums that's for that. This does take, it does not really say in the book, but it does take into account the new SEER 2 ratings that are out there for the federal minimums. It just depends on how, if it's tested for SEER 2 or HSPF 2, then there's different SEER ratings that needs to meet that efficiency requirements for that. Data centers, we talked a little about that earlier. There's an addition for that. So data centers shall comply with section 6 and 8 of the ASHRAE 90.4. So there is different sections that, even though it's in the IECC, they're going to reference the ASHRAE standard and have you go to that to actually meet those requirements. So the first one was replace design mechanical load component, the MLC value specified in the table, with the ASHRAE 90.4 values in the table C403.1.2 parentheses 1. It kind of just basically mimics that ASHRAE 90.4, and then replace the annualized MLC values specified in table 6.2.1.2 of the ASHRAE 90.4 with those values. So you just took the table values out of the 90.4 and put it into the IECC table, but there's different requirements with that part of it as well. But looking at that, they give you a table for maximum design MLC. So depending on which climate zone, it shows the design of what it should look like, and what your percentage or points for the maximum design for that MLC component. We've got a question here. Are you coming to Houston area soon? Yes, I am actually. And I will talk about that. I can talk about that after we end this this webinar. And then the next one was the maximum annualized mechanical load component. Again, it's based on climate zone, and it shows what you need to have in what climate zone that you're in. And then there's also fault detection and diagnostics. This is one big thing that was added, which a lot of them are getting confused with what we need to do, but most of it only involves if it's a condition floor area that's 100,000 square feet or larger, they must include fault detection and diagnostic systems to monitor the HVAC system's performance and automatically identify faults. In other words, if you've got a warehouse, which I've seen a lot of them being going up throughout Texas, if you've got a warehouse larger than 100,000 square feet and it is conditioned, or at least part of that warehouse that is conditioned is 100,000 square feet or larger, then it must have default detection or fault detection and diagnostics to say when the HVAC is having a problem, or when maintenance is now required, or if there's something that's now causing a fault to be triggered, it needs to email or somehow notify someone that the system needs to be have maintenance done to it. So it includes permanently installed sensors and devices to monitor. It samples the HVAC system performance at least once every 15 minutes. It automatically identifies and reports the HVAC fault that's happening. It automatically notifies authorized personnel somehow by email or if there's a dashboard that's attached. And then automatically provide prioritized recommendations for repair. So it could say this sensor fault has gone off. It may say something like sensor replacement required. And then be capable of transmitting in the prioritized fault repair recommendations to remotely located authorized personnel. There is an exception in R1 and R2 occupancies. Those are exempt from that, but any other type that's here must have that set up. That again is one of those things where we're not used to looking at it or inspecting it to see if it's properly running. We really don't know. We know it's installed, and then beyond that, we're kind of out of our control of what all does that system do? What all does that system monitor? But it needs to monitor the system. That way, a warehouse doesn't sit with a problem forever and ever and ever until somebody shows up on Monday to fix it. It's not wasting energy with that part of it. So Abdul, I see that you've raised your hand on there. If you want to, okay, here's a question. If you want to put the question in the Q&A and or the chat, I can answer it there instead of opening the mic and going from there. But Sean says, is this for a single HVAC system? Probably not, since that's much bigger than what a single HVAC system can handle. More than likely, it's going to be multiple systems installed. However, if there is a single HVAC system that can handle 100,000 square foot or larger, then yes, it's going by size of building, not really how many HVAC systems there are. So if that makes sense, it's going by size of building. If the building is divided into a tenant space, could this apply? That's one thing I've asked a few building officials, and they really didn't have, they just said they'll have to look at it. In other words, if you have a warehouse if you have a building that's 100,000 square feet and only 75,000 is warehouse and 25,000 is office, if the 25,000 office space is being conditioned, well, that isn't required here because it's less than 100,000. But if you're looking at a building as a whole and you're saying, well, the building's 100,000 square feet, you now have to have monitoring. It's almost going to be, there's up to interpretation to say, well, if the warehouse of 75,000 square feet is not being conditioned, why would you have to monitor anything there? So my opinion would be, if the warehouse is all being conditioned at 100,000 square feet or larger, it falls under this category. If it's split into half conditioned, half unconditioned, I would not think that you would need to have monitoring systems being installed for things that are less than that. Ben says the FDD requirement for high-rise buildings, if the total interior is 100,000 square feet. Yes, that's probably true. My thought process always goes to large single-story warehouses, but you're right. So if it's a high-rise building, it also is included with that as well. So the fire department would need to get involved with that part of it and look at that part of it. So there's just a lot of control systems that are happening and need to pull in with things that are larger than 100,000 square feet or more. Great questions with that. There's also automatic start and stop requirements now. And it says, in addition to automatic start controls, HVAC systems with direct digital controls serving individual zones must have automatic stop controls. So the automatic stop control shall be configured to reduce HVAC systems heating temperature set points and increasing the cooling set point, but not less than 2 degrees before scheduled unoccupied periods based on thermal lag and the acceptable drift in space temperature that is within comfort levels or comfort limits. The automatic start controls shall be configured to automatically adjust the daily start time of HVAC in order to bring each space to the desired occupant temperature immediately prior to scheduled occupancy. So if you have a system that's set up, and let's say it's supposed to come on at 7, when at 7 o'clock, it's going to drop it to 68 degrees. But for whatever reason, it's now 6:30 and it's already at 78 degrees. Well, the system should be able to come on prior to being occupied knowing that by the time someone occupies it at 7 and the system is on, it needs to be running to do that 68 degrees. So it can come on a little sooner to get there. So that way the comfort level is established instead of someone showing up at 7, it's 78 degrees, and it's going to run for the next 6 hours to get it to 68. It can monitor itself and actually be able to come on based on that lag time when it's got a different temperatures prior to occupant. So fan efficacy. So there's a fan efficacy metrics that's been updated to the fan energy index. Basically, it's that FEI providing consistent fan efficiency requirements across the IECC, again, and the ASHRAE 90.1, and resulting in a more effective or efficient energy savings metric. So a lot of those, each fan and fan array used in a variable air volume, a VAV system, shall have an FEI, which we just talked about, of not less than 0.95 of the design point of operation, as determined in accordance to the AMCA 201. So the AMC is basically the Air Movement and Control Association. It's their standard and guideline. It's a free download if you want to go to amca.org. There's a free guideline that actually shows that. And then the FEI of fan arrays shall be calculated in accordance also to the AMCA 201 Annex C. So a lot of this is done based on another standard. They're referencing that standard that you need to reference to be able to figure out if the fan efficacy or efficiency is meeting the requirement of the IECC. So low capacity ventilation fans. So mechanical ventilation fans with motors less than 1/12 horsepower must meet the fan efficacy requirements in table C403.8.5. So basically it's a new requirement for low capacity ventilation fans. So kind of like what we call in residential fresh air. So those fans that basically apply the ventilation for that, for both residential and commercial, to mid-rise residential occupancies and small commercial buildings. There again is exceptions, which are fans that are a component of the HVAC system. So if it's not a standalone and it's part of the HVAC, it's exempt from this requirement. Or dryer exhaust duct power ventilators, domestic range hoods, and domestic range booster fans that operate intermittently. In other words, if you have to have fans that come on for higher exhaust for dryers and or range hoods or domestic range booster fans, those are also exempt. This is just showing the low capacity ventilation fan efficacy table that's now part of the code. But as we can see, if it's an ERV or an HRV at any CFM, it must now meet the 1.2 CFM per watt. And then you've got an inline fan, which is also considered a booster fan, or if there's an inline, not in with the range hood, but an inline fan for some type of kitchen exhaust, or like a dryer exhaust. If it has a booster fan on it, it must meet the 3.8 CFM per watt of any maximum or minimum CFM. And then bath fans and utility fans, you've got a minimum of 10 watts, lower than 10 CFM, lower than 90 CFM. You must meet a 2.8 per watt or CFM per watt. And if it's larger and it goes from 90 to any other CFM at maximum, it must be 3.5. Basically, you're looking at how many watts, how many CFM per watt draw is actually this fan accomplishing. And that's a new thing for efficacies that are coming in residential as well as for commercial. They basically just don't want a high watt draw powered fan pulling in very minimal airflow. That's another reason why in residential, if you're doing performance or if you're doing Energy Star and you're doing modeling, you cannot use the air handler as its fan source for mechanical ventilation, because the watt draw for the air handler is too large and it will not meet this requirement of fan efficacy, and it draws too much power for such low CFM. And then operable opening, so interlocking controls. We talked about that earlier. That was specific to like a restaurant style. But as you can see here, this is a warehouse with a loading dock. You've got curtains on the side and the top. So it's saying heating and cooling systems must have controls that interlock the mechanical system, same as the other. but the controls must configure to shut off the systems entirely when the outdoor temperature are below 90 or above 55 degrees. So also on that, it references section C402.5.8, and it references loading docks and the requirement for weather seals that restrict infiltration and provide direct contact along the top and sides of the vehicles as they're parked at the doorway. So with this, as you can see, you've got an 18-wheeler or delivery truck that's pulled up there. You've got curtains on top and sides that's keeping that air movement from happening as those doors are open. But at the same time, you've got the interlocking controls that's happening based on outside temperature. So if the outside temperature is acceptable below 90 degrees, then it just shuts the system off. If it's above 90 degrees, then it's going to basically, it will raise that temperature based on the outside temperature, or lower it depending on if it's heating or cooling at that time. So it's going to adjust the way it needs to adjust to counteract the loss of conditioned air throughout those loading dock areas. So with that, we're about 52 minutes. The next section is getting into that electrical power and lighting like we had done before. And so I'm just going to go ahead and end the recording here. If you guys have any questions right now, you guys can feel free to ask at this point and we'll go through it. But I will stop the recording and we'll just open it up for discussion if anybody wants to stay on and go through that. But again, thanks for joining us. And this will be uploaded into our YouTube channel as an update. There are others that look like this. I've been just trying to update with more information. It's been also requested that I add more pictures and more real life examples of what we're talking about instead of just reading the code language. So that's what I'm trying to do with that part of it and bring you guys into seeing what it looks like when it's compliant or seeing what it looks like when it's non-compliant. So again, thanks for joining us. I will end the recording and then we will just open up for Mike and I will stay on for a few minutes just to see if anybody's got a question.